Welcome back to Topic 7 for Algebra 1, Write, Solve, and Graph Linear Inequalities. In Part 1, we're going to learn the basics about inequalities, including some vocabulary, how to graph them on a number line, and how to shade them on a number line. For this first slide, I want to introduce you to some code words. So feel free to take a moment and pause. We have code words for less than, equal to, greater than, less than or equal to, not equal to, or greater than or equal to. Sometimes when reading word problems, they don't actually list explicitly, this is less than, this is equal to. Instead, they have these other words, what I'm calling code words, which mean the same thing, but just keep that in mind when you are reading word problems so that you don't get tricked up. Okay, let's start with the basics with graphing a number line. So first, I'm just going to draw a number line. Same one that you drew back in like elementary school with 0 in the middle. Okay, now to the left of the 0, our numbers are negative. To the right of the number line, our numbers are positive. As we go to the left, our numbers keep getting smaller and smaller and smaller, more negative. And as we keep going to the right, our numbers are getting bigger and bigger and bigger. So on the left, as we're getting smaller and smaller and smaller, this is less than. And on the right, as we're getting bigger and bigger and bigger, this is greater than. And actually, where do I see the inequality signs? But right here. So on the left, this is our less than symbol, and on the right, this is our greater than symbol. They actually have been there all along. Okay, now when graphing inequalities, we deal with shading. So shading indicates that the values are solutions. And we deal with this with circles and also shading on a graph. So first we have a closed circle, which is basically a dot that is filled in. We know to graph a closed circle when we have either a less than or equal to or a greater than or equal to. This means that the endpoint is a solution. So wherever that circle lies, whatever point that is on the graph, that is a solution to the inequality statement. The opposite is an open circle. So our circle here is not filled in. This is when we're dealing with strictly less than or strictly greater than. So we don't have that inequality bar below it. I'm sorry, the equal bar below. This means that our endpoint is not a solution. In my example below, we're asked to now shade in the appropriate direction of the number line. So my first example, I have x is less than 3. So I'm going to draw my number line first. Now feel free to just draw 3 at the center of your number line as long as you indicate what your value is in the number line. Number lines go towards infinity, either positive infinity or negative infinity. So just indicate where you're referring to. You don't need to draw a 0 and then draw on both sides. Label all of the numbers. That can just be tedious. Since we have x is less than 3, we know that this is an open circle. And because x is less than 3, this means that x could be all of the values that are smaller than 3. So in this case, we're going to shade on the left-hand side of our number line. For the next example, we have x is greater than or equal to negative 7. So I'm going to draw my number line, label my negative 7. Here, since x is greater than or equal to negative 7, this is going to be a closed circle. And since x is greater than or equal to negative 7, that means that x is bigger than. So we're going to shade all of the values to the right. Now there is a trick when shading on an inequality line. However, this only works if we have our variable listed on the left. So for example, in my examples here, we have x is less than 3 and x is greater than or equal to -7. This trick does not apply if your variable were on the right-hand side. So if we look at our inequality, they also kind of look like arrows, just as we indicated on our number line. So we're going to shade in the side that arrow, the inequality, is pointing towards. So since x is less than 3, my inequality is pointing to the left, which is why I shade to the left. Or since x is greater than or equal to -7, my inequality is pointing to the right, so I'm going to shade to the right. And again, this only works when the variable is listed on the left-hand side. Let's go through an example. Sometimes we might deal with actual word problems and we're asked to graph them. So in our first example, I can walk up to a maximum of 5 dogs at a time. So we're first going to draw our number line, label our 5. Now, quick question. If we look at our keywords here, we have a maximum of 5 dogs. Can I actually walk 5 dogs? Yes, I can. So I'm going to have a closed circle here. Can I walk 4 dogs, 3 dogs, 2 dogs? I can. Can I walk 6 dogs, 7 dogs, 8 dogs? No. Because 5 is the maximum amount, the number of dogs that I can walk is 5 or less. So I'm going to shade to the left-hand side. Now I'm also going to write this inequality just for reference. This would be x is less than or equal to 5. And if we think back to our chart, we see maximum right here. You don't need to memorize the table, but it can come in handy when we're doing word problems such as this. Now, another way that I can rewrite this inequality would be if 5 is greater than or equal to x. If we think back to in elementary school when students learned about like the alligator or the crocodile eating the bigger number, here x is less than or equal to 5, so it is eating the 5. So if we wanted to rewrite it with our variable on the right-hand side, our inequality still needs to eat the larger value, so we are going to flip our inequality when we actually flip our number in our variable. So just keep that in mind. Our next example, you must be more than 50 inches tall to ride this ride. So we have our number line. We're going to label 50. Now, you must be more than 50 inches. Can I be 50 inches tall and actually ride the ride? I cannot. So this is going to be an open circle. Can I be 51 inches, 52 inches, 53 inches? Yes. So I can be all of the values that are taller or greater than 50 in this case. Can I be 49 inches, 48 inches, 47 inches? I cannot. So x must be greater than 50. And that was part 1 for topic 7 for Algebra 1, Write, Solve, and Graph Linear Inequalities. Thanks for watching.